Hi all. So we're introducing this new Python secure coding guide. So this started as an internal Ericsson project, which we've decided to open source. And the reason for wanting a guide is we currently come from a team that does a lot of work with Python, such as like configuring Ansible scripts and deploying services into cloud native, and you're configuring Apache servers with Python, and it's to make sure that everything is properly secured. So there was a lot of like secure coding resources out there for kind of C++, Java, but not much for Python. And it was a bit strange for ourselves as an almost purely Python coding team to have to be like, okay, guys, well, you did great, and we need you for doing Python code, but actually, can you go off and take these C resources to learn secure coding? It didn't really make much sense. So I suppose this is where this started, is we started internally to make our own documents, because both myself and Bart here, we worked as security masters within the team. So what our job is basically is to make sure that everybody understands secure coding and to drive that within the organization, and to spread word about the latest CWEs and vulnerabilities and the latest static code analysis tools and stuff like that. So we wanted something that was very relevant to our own team, and we've had the opportunity to work with the OpenSSF and to actually open source this project, which I think is great, to be able to open this up to the community and get more eyes on it. So basically what we wanted just easy to understand training material for new recruits on secure coding. It's supposed to be from coders for coders, which is like easy to read, easy to understand. It's supposed to be just, you download it, you run it, and off you go. It's supposed to be very straightforward with as little fluff as possible to reduce the study time. Like, we don't want to be wasting developers' time having to do the secure coding, because they have to do it every year. So like the faster they can do it and the less that we spend on it, the better, right? Now, as we say, like it's better to open it up to the community to get more eyes on it, and to have people to critique it, and wanted as many people to get involved as possible in kind of enhancing the material, and providing good feedback. So we have had an opportunity to actually go talk to people like CWE, and they've allowed us to use their enumeration system. So that's exactly what we're using that as part of our guide. So what you'll see like a vulnerability, like a common weakness enumeration, and then a description of how to implement that in Python, and then how to fix it. Right, so Bart is going to do a demo of some of the examples that we have, and hopefully you get something from it, and you're able to help us out and contribute yourselves, and that's what it's all about. So I'll leave it to Bart.
So I picked an example I found interesting anyways. It's based on CWE 410, and it's insufficient resource pools. So all it is, as you can see, the coding examples are quite short. This one's 47 lines, for example. And there's a compliant example. This is how we work. We basically try to mirror the non-compliant example, change it to the compliant one, and with just additions to make it more secure, I suppose. So this one specifically, it's a very easy one. It has a message API class in it, and all that this class has is an add messages function. But what you will see basically is that every time a message gets passed, or a list of messages gets passed, what the function does is for every message, it starts a new thread and calls the process message function, which processes the message. So theoretically great threading, so we can process all the messages concurrently. However, what happens when an attacker comes along and, for example, sends 10,000 messages at one time to the function? So I can actually show you exactly what happens to the CPU. We have for example, 8% utilization here, we can run this non-compliant example. And you can see that my laptop is going to be close to blowing up in a second. So we'll turn it up. We'll turn it off for now. And well, I'll show you how to fix it, I suppose, with the compliant example, which is what the compliant example does. So the compliant example has the exact same message API class. It has the add messages function, and it has the process message function, which it calls as well. However, the difference in this one is that we use this thread pool executor. And this thread pool executor, what it does is it sets a hard limit of the amount of threads that can get started at one time based on a max workers parameter limit. So the max workers default minimum is either 32 or the amount of cores plus 4. So that is the maximum amount of basically threads that can get started. And we set a timeout. Now, realistically speaking, the timeout should not be hard-coded like this, and it should be computed like, I don't know, depending on the mediation layer. But just for this example specifically, we're just talking about insufficient resource pooling. So we left it as simple for programmers to understand as possible, and we hard-coded it to be 1 second. And essentially, what we then do is we execute it using this this futures array, which has all the future objects in it. So to this array we append basically these processed messages, and we can see what happens when I run this. Essentially, it will be it will have only a certain amount of messages processed, and the others will not get processed in order to essentially save your resources. So, of course, this is also not the most efficient way to solve the issue. However, we sort of try to tackle the issues sort of example by example. So realistically, more stuff that we should be doing here is stuff like sanitizing the input and limiting the amount of messages that can actually get sent by the attacker. But of course, we try to keep the examples as simple as possible for programmers to understand per example. I suppose another thing is the attacker could, in response to this, create a load of message APIs and could still sort of overload the resources and cause a denial of service attack, in which case we would also need some sort of proxy that would detect some intrusion detection proxy. So yeah, I suppose what I can show you then as well is the way this actually looks on the GitHub page, which we have this README, and as you can see, the amount of text is really kept sort of to a minimum. We have a paragraph explaining the problem at hand, explaining that a denial of service attack can happen. The coding examples themselves, we try to keep to an absolute minimum. So 2 lines here for a non-compliant example. We really try to drive home the point that programmers don't want to be looking at walls and walls of text. Programmers want to pull down a repository. They want to, run the code example. They want to see what happens to the actual case. So it is as little amount as possible, I suppose, of text, and as little code as possible, as well as easy to understand. But yeah. So I will go back to the slides. Do you want to present?
Yeah. So as Bart was saying, like that's kind of the idea we're working on. So it's, to have clear, concise code examples. We wanted the code examples to be reviewed by as many people as possible to get their feedback and to improve them. Because like the last thing we want is a code example that doesn't clearly fix the issue, or there's other problems that may occur that we haven't handled. So as I said, each code example is supposed to give an example of one specific error. So some of them, as we say, they're not fully sanitized. You can see they're not like fully robust examples. They're examples of a specific use case. If you kind of get the point. Anyway, we're looking for people to join and to contribute. We have a meeting on Slack, and you can also contribute on GitHub and become an OpenSSF member. So if you'd like to do any of that, we do have a link to these slides with a QR code or a GitHub code if anybody wants to take a picture of it. It's also open scaled, so you can just download these slides, so that maybe that's easier for you. Is there any questions that you have? No? All good? All good. It looks like we're all good, right? So sort of short and sweet, lads. That's kind of all we have to show you. It's just code examples, and do we have time? I suppose we have time. We could.
I think I would have one question.
Yep.
Yeah.
Can you think of an example that is really Python specific that doesn't show you anything that would be in a tutorial or a secure coding guide for another language?
I can't think of one right now necessarily off the top of my head, but I suppose we're. Oh, sorry. You can go ahead.
There is one or two about like things like package management and Python, and also like signing packages and stuff like that, and making sure that you're not pulling in, what we're always saying about supply chain security. So it's just making sure that your Python packages are coming from the right source, right? So it's very straightforward in that sense. But yeah, there's those kind of ones, but the vast majority do exist in other languages. As we say, we want a guide, like there does exist guides in C and C++ and all the rest. So you can give people, it's very strange to say, hire a Python programmer and then give them a C guide and say, look, this is, learn the C guide for programming,
Of course. Is there anything about pickles, the pickle module?
There is, yes.
Oh, good, great, thanks.
So there's also things like zip bombs, SQL injection attacks.
There's a lot of logging ones as well, like insufficient logging ways to combat that, I suppose.
Yeah, and then issues around like the use of the rounding function that sometimes it automatically it's not. We found that the normal round command can either round up or round down, but it's kind of non-deterministic, and it kind of like there's like a rounding dot round up that you should use instead of the ordinary round. So it's like there's strange ones that you think that it would always round up or always round down, and we found is like for like 1.5 it goes to 1, and for 2.5 it's going to 3, which is like strange, but that is what it's doing. So yeah, that these are the kind of things that we're finding. So like I don't know what you call that Python specific, because it's like how Python is handling numbers. Like there is ones of like the numerical handling of numbers in Python, which is slightly different from other languages, and how they've like coded the C backend, so that is kind of it. Like we could flick through the GitHub, but like I think like it's easy enough for you to go to GitHub on your phone and look through other examples. There's about 70 or 80 of them in it. There's definitely more to be put on GitHub that we have just in Ericsson internally.
There's currently a few as well with no readmes at the moment. So we're also the way we work is first we do the coding examples and then we add the readmes afterwards. So yeah.
They said it's like it's not anything unusual. It's stuff you would have seen in other programming languages. It's just to have something for Python developers, really. Guy at the back there.
Yeah, so this is not a question, this is more like a shout out. So we are a static analysis company, and upon seeing this list, even though that was not intended, we asked our developers to basically have a look at the list and see like what kind of bugs are we detecting and are there gaps. And so having this list, it helped us identify those gaps, and so that was not probably what was the intended part of the process of the project, but it helps the community in other ways. So that's the shout.
That's
No, I think that might be worthwhile pointing out to them as well. It's just if you scroll down to the bottom of these code examples, I don't think you did, Bart, but at the very bottom you can see like relation guidelines. So, like as we say, is this information available in other places? Yes, because it's coming from other places. It's coming from like we cite all of our sources and we get permission from all of our sources. So like a lot of this, like people have came to me the other day in the boot and say it's very like the say cert. I said it is because like they are one of our references, and we've called those guys and gotten permission from them to use that material as well. And there's also like automated detection, as we say. This one is unknown, so I don't know. It's just not been updated. But I think if I go to one of the other ones, there's probably an example where they give. I don't know. Is there one with a README here?
That's actually the one we have open.
Yeah, hang on. There's probably another one with a README. That also doesn't have one. So, like, this one is saying there's currently none, which basically means that nobody's detected this. So, like, none of the static code analyzer to detect this. Trust boundary violations, I don't know. Is there any? No. Oh, God. Let's see. Deserialization. I think this is the pickle one, isn't it? Yeah, somebody mentioned about pickle. This is the pickle one. Yeah. So you can see a non-compliant pickle example there. It is quite complicated. Like we do try and keep it as simple as possible, but pickle is quite complicated to implement, and it's quite quite complicated to show a working vulnerability in it as well. But I think there is, as you see here, there is an automated bandit detection. So if you're using bandit, it will detect it. So that is one of the things we do is we go through all the static code analyzers, and if we find ones that actually do detect it, then we write it down. So as the guy in the back was saying, it's an unintended consequence of this is that we found that certain static code analyzers are not detecting certain problems and others are. But yeah, that's kind of the project. I think we're nearly we're over time, so we'll probably have to leave it there, but feel free to give us a shout out. You have the slides online, and hopefully you find it interesting and useful. Like, as we say, nothing unusual. All right.
Thank you, everyone.